So dear students, we begin our journey of problem solving, and this is the first video regarding problem solving in physics. And all of you know that problem solving is a very important part for your board exams, your school exams, competitive exams. If you just understand the theory of physics, it is not enough. You have to solve problems. So this first problem is regarding motion or regarding kinematics. So I have chosen a problem which is regarding motion under gravity, when objects are thrown up or down under gravity or dropped under gravity. So we will be solving a lot of problems in different topics, beginning with kinematics, which I am going to deal with today. So this problem is written on your board, and I would like you to have a moment and read this question. So it says that two particles are thrown from the top of the building. One particle is simply dropped, and at the same time another particle is projected vertically upwards with a speed of 40 meters per second. The building is 80 meters high. When the first particle reaches the bottom, where is the second? So the first part in problem solving is always to understand the question properly. This question simply says that there are two particles. This one I simply drop from this building, so it starts falling down. At the same time, I've thrown it upwards. Now often such kinds of problems confuse us, because I am talking of the first particle. I am saying when the first particle reaches the bottom, there is a second. So we are often confused, how are the two related? And of course the two are related, and that relation is because of time. Now when you drop this particle, it takes a certain time to come down to the bottom of the building. And during that time, we need to find how much has it traveled. Is it like still up the building, or has it come back to the same point, gone below that point? That will help us decide where it is. So there can be two ways of solving this problem, and first I'll draw a figure, a rough figure, and then I'll begin solving this question. So we should remember the data that the speed is 40 meters per second for the second particle, and this is simply dropped. So we also need to understand wherever in physics they say simply dropped, it means there is no initial speed, there is no initial velocity. So u is 0, and g they have given as 10, the height of the building is 80. So I am rubbing it and drawing a figure for all of you. So you should always be able to draw a rough figure at least for every kind of problem. So this is a building, and it says that the height of the building is 80 meters, let us say. This is the bottom of the building. So there are two particles. This is first particle, and this is, let us say, very near to it is second. Both of them are at the same point, but in figure you can see that they look separated. So once you drop this, you can say that the u for this particle is 0, and it has to drop all the way to the bottom of this building. And g we have been given as 10 meters per second square. Actually it is 9.8, but in many problems we take it as 10. Now at the same time, this particle is projected vertically upwards, and let us say its initial velocity, which I am writing as u prime or u dash, is 40 meters per second. That was the question. Now first I'll tell you the fundamental approach, and then a little quicker and more advanced approach, and that is the fun of physics, if we can find out a little better or shorter way to solve a question. Now let us first find the time this particle takes to come down to the bottom. So this is a very simple problem, and all of you should remember that when you drop something from a height h, the time it takes to come to the bottom is simply given by root of 2h by g. So this you simply get by writing h is equal to half gt square, and u is 0. Now when you solve this, then you will get 2 into 80 upon 10, so it is square root of 16, which makes it 4 seconds. Now we have got the time in which this particle comes to the bottom. So the question becomes immensely simple. Now the time was the connecting factor, I told you. And cannot we find where is it after 4 seconds? That is this particle. Of course we can do. So we don't know its displacement. Suppose it goes up and up and up, and then maybe it is here, I don't know. So I will use the equation S equals to ut plus half at square. And remember, we are dealing with the vertical direction. You can say it is y-axis. So when you throw it up, then very important in problem solving is the sign that you give. Here I am taking the upward direction as positive and this direction as negative. So since the upward direction is positive, u is positive for this. So we will say S. You can also write H if you want, but I am writing S equals to 40 into T. T of course has got no sign, plus or minus, plus half. Now this is downward direction, and we know that acceleration is always downwards, and therefore acceleration is always negative if the upward direction is positive. So 2 into, be careful, not 10 but minus 10 into t square, and that solves our problem. So what we get is 40, and just put the time as this now. So 40 into 4 plus half into minus 10 into 4 squared. So that becomes only 160 minus 80. So it is 16 by 2. So I get 80 meters. So it basically means that this answer is plus 80. So that means when this reaches the bottom, then this particle is somewhere possibly here. It's going out of the board because it's 80 meter on top of this building. Now how do I know? Because if my answer had been minus 80, it means this particle would have traveled all the way up and come down. Why? Because minus 80 means downward 80, but my answer is not minus 80, my answer is plus 80. So when this particle reaches the bottom, that is 80 meters, then this particle is somewhere here, that is 80 meters above this building. Now could we have solved this problem in a better or easier way? So this is what is required when you attempt like competitions like NEET, or let us say JEE mains or advanced even. So if you are able to solve problems up to JEE mains, NEET, you can do JEE advanced problems also, of course. So there is another approach which is very interesting, and that is the approach of relative motion. And if you are able to figure it out, then this problem becomes very easy. Now very interesting fact I am going to tell you, which I told you in my lectures also, if you look at those lectures. And that was for any two particles which are falling under gravity in whatsoever way. If you throw it like this, drop it here. So those two particles have zero relative acceleration. Many students are not able to go to the depth of this. This is very interesting. This is very interesting. So when you consider these two particles, I can say that their relative acceleration is zero. So many times students think, so what is the big deal about it? If it is zero, then what? But there is actually a big deal. So you should understand the significance of this. When I say relative acceleration is zero, in the first place, why I am saying relative acceleration is zero? Because all particles falling under gravity have the same acceleration, that is g. Same acceleration. So if two objects have the same acceleration, their relative acceleration is zero. If two objects have the same velocities, their relative velocity is zero. So relative acceleration is zero means something very interesting, and that is relative velocity is constant. If you just understand the small things, I bet you can crack any competitive exam. Take my word for it. Like, why I am saying relative velocity is constant? Why? Because see, if the acceleration is zero, velocity is constant, you know, because acceleration is the rate of change of velocity. Now when relative acceleration is zero, it obviously means that relative velocity is constant. So when I am saying relative velocity, I mean to say velocity of this as seen from this, or the velocity of this as seen from this. So velocity of one as seen from the second is a constant, and that is very important. So although we have g as 10 meters per second square, but let us see what happens. Now in the first part, as usually, I calculate the time. So the time it took to fall down, I am repeating, was 2h by g from this, for this particle, and now I name it as A and this particle as B. Just look what happens. So this time you already got as 4 seconds. You can just rewind and see if you forgot in this small time. So 2 into 80 upon 10, g is taken as 10, so it is only 4 seconds. Now can we get this answer really quick without having to waste much time? Now you can see that this u is 0. So if I calculate the velocity of B, just remember what I am doing. I am writing velocity of B, this one, as seen from A initially. Initially, what was the velocity of this as seen from this? So it always says that this means velocity of B minus velocity of A. This is the meaning of relative velocity. जिसके रेस्पेक्ट में आप निकालते हैं उसकी वेलोसिटी को आप सब्ट्रैक्ट कर देते हैं. सो यू बी माइनस यू ए, यू आर फाइंडिंग विद रेस्पेक्ट टू ए. सो यू ए इज ऑब्वियसली जीरो. व्हेन आई एम सेइंग यू इज जीरो, इट इज यू ए जीरो. यू प्राइम मीन्स द वेलोसिटी ऑफ दिस इनिशियली, यू इज द वेलोसिटी ऑफ ए इनिशियली. सो दिस इज नथिंग बट ओनली 40. सो सी, very interesting. So I am saying nothing, I am simply saying that initially this particle is moving with 40 meters per second. So this is plus 40. So it means as seen from this, it is going up with a speed of 40 initially. But this is the punch. This is the punch of this problem, and this will help you solve many problems. Now you can see that since relative velocity is constant, so this remains constant. Isn't it wonderful? Their velocities may be changing all the time. It will slow down, it will speed up, but their relative velocity will be constant because the relative acceleration is 0, and that is the adventure of this problem. Now if relative velocity is constant, then it becomes a very simple problem. You know, when velocity is constant, what you say? You say that displacement s is equal to velocity into time. Your basic school physics. Velocity is speed up. Velocity is distance upon time, where here s is displacement. So displacement is velocity into time. So if this relative velocity is constant, can I write that the relative distance, when I am saying relative distance, the distance between the two would be nothing but this, that is constant relative velocity, this thing. So it will be, this is actually, we can also call it as u relative. So this is nothing but u relative into time, and I already calculated time above in which it came down here. So very easily you get 40 as the relative velocity. Time is this, the 40 into time, that is 4, and the answer is 160 meters. So as relative means the displacement of this particle B with respect to A is 160. So you will say, sir, but this is the wrong answer because we got the answer as 80 meters. You said that it is at 80 meters above that building. Look carefully, this is the same answer. Now what I am getting is that with respect to this particle is 160 meter high above. You understand this? This is relative. We often forget the word relative. So when this comes down to the bottom, so with respect to this particle, the other particle is 160 meter plus. So if you take 160 meter from here, where do you go? You go up 80 here and then 80 more. Why? Because this is 160. So out of 160, if you subtract this 80, then where is this particle B which you threw upward? So I can now say that B is at a height, how much? That is 160 relative to this. It is 160 from here, but then subtract 80. So minus 80, the answer is 80 meters. What is the big deal about this solution? The big deal is we didn't have to apply ut minus half gt square and things like that. So using my relative velocity approach, I have solved it very easily. Just I knew that relative speed is 40. I multiplied with the time it took to fall down and calculated it as 160. So with respect to this is 160, so you can say it's 160 meter above this point, or you can say 80 meters above the top of the building which solves our problem. So you can see how two different approaches help us solve problems in a really shorter and quicker way. So we will be solving a lot of small problems, building up our concepts. Thank you for attending this video. I'll see you in another video on another problem. Thank you.